Hello students, we have covered continuity, so now we will move on to differentiability. Okay, so what is a derivative of a function? Derivative means if you have say a function k f of x. So x-axis it is for values of x and for y it is your f of x, right? So this is a function. So whenever you get a what do you say, a slope, okay, that slope gives you the derivative, that is we write dy by dx, right? Change in y with respect to change in x, this is your derivative. Okay, so differentiability, if you have a function f of x, the derivative of f of x is denoted by f dash of x, right? Or d by dx of f of x, okay, or f dash of x. So f dash of x as limit h tends to 0, f of x plus h minus f of x upon h. This is the derivative. Okay. Wherever the limit exists is defined to be the derivative of f. Okay. Now the process of finding the derivative of a function is called differentiation. Okay, the process through which we find the derivative of a function, it is called differentiation. So if your f of x is given y, then we write derivative as dy by dx. Okay, so there are certain rules. That is, first rule is product. Product is uv dash, dash is the derivative. Okay, how we denote it. So this is given by u dash v plus uv dash. Okay, this is a product rule. Then we have u by v rule, that is u dash v minus v dash u upon v square. Okay, here you can remember this. You have to put u dash v first. Okay, go according to product rule. Sometimes students get confused with whether v to put first or u. Okay, so start with u dash v minus v dash. So u dash and v dash are the derivatives of u and v. Okay, then you have addition plus or minus v. Then we have u dash plus or minus v dash. Okay, this is called product rule or Leibniz rule, and this is called quotient rule. Division is there, right? Now a function is said to be differentiable in an interval close bracket a comma b if it is differentiable at every point of a comma b. Okay. Then we have a theorem, if a function f is differentiable at point c, then it is also continuous at that point. Okay. If it is given that the function is differentiable at some point c, okay, then it implies that the function is continuous. Okay. But its converse is not true. That is, every differentiable function is continuous, but every continuous function is not differentiable. Is every continuous function is not differentiable. And the example for this is f of x. If you take mod of x, okay, this is continuous. We have proved this, okay, but it is not differentiable. That is, if you take limit as left hand limit, left hand derivative, okay, as h tends to 0 minus f of x plus h. X is we have taken 0, uh, minus f of 0, okay, upon h. This is, if it is 0 minus, that is we are approaching from the left hand side, the value of mod of x is negative. So this is minus 1. Similarly, for right hand derivative, we take limit as h tends to 0 plus. Okay. This is 0. Here it is minus 0 minus h. And this is positive 1. Okay. So left hand derivative and right hand derivative are not equal. Okay. Hence f is not differentiable at 0. Then we start with the derivatives of some functions. So derivative, first is composite function. Composite means you have one function and inside there is another function. That is, we can say that suppose you have sine of x and there is another function x square. So there is a function inside that another function. Okay. So its derivative d by dx of sine x square is, first you have to write derivative of sine of x. What is the derivative of sine of x? Cos, right? Into derivative of x square, that is 2x. So two functions are there, right? So cos x square into 2x. This is the derivative. Okay. Composite function, that is this is your say h of x and this is g of x. So it is h composite g. Okay. Then we have something else, chain rule. So this is actually solved by chain rule. These two functions are there. So one function derivative is written first and then another function. Okay. Let's take another example. See, tan of 2x plus 3. Okay, d by dx of this is, first you have to write derivative of tan of x. That is, this you have to keep as it is. So tan of x is x square 2x plus 3 into derivative of 2x plus 3. Now we know that derivative of 2x is 2 and derivative of 3 is 0. So this is 2 x square 2x plus 3. Okay. So first you have to learn what are derivatives, which we have done in 11th standard. Okay. So you should know what is the derivative of what. That is the least you should know. Now differentiate sine cos square with respect to x. So this first you have to differentiate sine. Sine becomes cos. Okay. Then differentiate cos. So this is minus sine x square. And then you have to write derivative of x square, that is 2x. Okay, it is very simple. Okay. I'll just write the derivatives. Okay, how a derivative is given. First is if you have d by dx of x raised to n in general, then the derivative of this is given n x raised to n minus 1. Okay, that is if you have x square, derivative of this is n is 2, right? 2x raised to 2 minus 1, that is 1, so 2x. Okay. Now derivative of a constant function, any constant function, say a is 0. Any constant function is 0. When you are finding derivative, it has to be in terms of x. If you are derivating in terms of x, then it has to be in terms of x. Then only you can write the derivative. Otherwise, it becomes a constant. So constant will get 0. Okay. Then the derivative of trigonometric functions, sine of x is cos of x. Derivative of cos of x is minus sine x. Then derivative of tan x is sec square x. Then the derivative of cosec of x, first I will write sec of x, is sec of x into tan of x. Then derivative of cosec of x is minus cosec of x into cot of x. Then derivative of cot of x is minus cosec square x. Okay. Any other derivative? Then in this chapter you will be learning derivatives of inverse trigonometric functions. Okay. Then we have exponential and logarithmic functions. Okay. Derivative of exponential, that is e raised to x, is e raised to x. Okay. Then the derivative of log of x is 1 by x. Okay. Then there is one more, that is e raised to x, right? Derivative of a raised to x. A raised to x is a raised to x log a. Okay. I'll write inverse trigonometric functions also. Okay. That is if you have sine inverse. Okay. Sine inverse of x will get 1 upon root of 1 minus x square. Okay. This sine inverse of x and cos inverse of x is similar. Only thing is, for cos inverse of x you have to put here minus 1. Okay. Then we have tan of x, tan inverse of x. Tan inverse, it is 1 upon 1 plus x square. So for cot inverse it is negative, minus 1 upon 1 plus x square. Okay. For sec inverse is 1 upon x root of x square minus 1, and for cosec it is negative, square minus 1. Okay. So let's solve some other examples. Derivatives of implicit functions. Derivatives of implicit functions. Okay. So implicit means what? You'll have, say, function is given y is equal to fx. We say that y is given as an explicit function of x. Okay. And in later case it is implicit that y is a function of x, and we say that the relationship of the second type. Okay, so if you have, say, examples they have given x minus y minus pi equal to 0. So here we can write x and y separately. That is y I can write in terms of x. That is y becomes equal to x minus pi. Okay. For second example, it is given x plus sine xy, okay, minus y equal to 0. Here xy is the you say angle of sine. Okay, we can't separate here y. So this becomes your implicit function. Implicit. Okay, this is implicit and this is explicit. Okay, so let's find out. Okay, let's solve. So there is one difference while solving this, that is you have y plus sine y equal to cos of x. Okay, you have to write derivatives directly. Okay, so y, when we derivate with respect to x, we differentiate with respect to x, what we write? If it was x, then when we differentiate with respect to x, then we write this as 1. Okay, but here when you are differentiating with respect to y, you have to write dy by dx. If it was y square, okay, then it was 2y dy by dx. So every time you see y, okay, in between, so you have to write dy by dx for its derivative. Okay, so this y is dy by dx plus here now two functions are there. Sine is there and y function. Okay, two functions are there. And we are derivating them, differentiating them with respect to x. So sine of y becomes cos of y into, chain rule you have to apply, into derivative of y, that is dy by dx. Okay, equal to, here it is a function of x, so directly you can write derivative. Cos of x is minus sine of x. Okay, now we want answer in terms of dy by dx. Okay, so dy by dx you can take common. This is 1 plus cos of y minus sine x. Okay, so dy by dx is equal to minus sine x upon 1 plus cos y. Okay, next we are going to see derivative of inverse trigonometric functions. Okay, so if you are given f of x equal to sine inverse of x, so here you have to apply knowledge of inverse trigonometry. Okay, that is, you should know what is the range, what is the domain of this function. Okay, so we can write this as equal to some y. So our sine y is x. correct? So if you differentiate with respect to x, both the sides you will get sine becomes cos y into, it is implicit function, so dy by dx equal to 1. Okay? So dy by dx is equal to 1 upon cos of y. Okay? And y is nothing but sine inverse of x. Okay. Now see that this function should not be equal to 0, right? Because it is in the denominator. Then only this becomes defined. Okay. So your cos y should not be equal to 0. Okay. And this sine inverse of x should belong to uh, cos y should not be equal to 0 means the value of y cos 0, 1, 0, cos of pi by 2. Cos pi by 2 is 0, right? So this y should not be pi by 2. Okay. So your sine inverse of x should not be equal to pi by 2. Okay. Plus or minus pi by 2. So if it should not be equal to plus or minus pi by 2, then this x should not be equal to minus 1 or plus 1. Okay, that is, it should not belong to closed interval minus 1 to 1. Okay, here minus 1 and 1 are included if it belongs to the open interval, that is minus 1 and 1 are discarded. So should happen that x should belong to minus 1 to 1 open interval. Okay. Yeah. So if this happens, then we can write that sine of sine inverse of x is x. This we have seen in our inverse trigonometric functions. Okay. So we can write, so we will be using the what you say, sine square y plus cos square y is equal to 1. This is trigonometric identity. Okay. So you can write cos square y in terms of sine 1 minus sine square y. Okay. So sine square y we have taken, y is our sine inverse of x. Correct? So we can write here sine of sine inverse of x square. Okay. And we have just written that sine of sine inverse of x is x. Okay, for x belonging to minus 1 to 1, open interval minus 1 to 1. So we can write this whole thing as x and x square. Okay, and cos square y and minus x square, right? Yeah. So this is cos square y. So cos of y will be root of 1 minus x square. So coming back to our derivative was dy by dx equal to 1 upon cos of y, right? So in place of cos of y, you have to write root of 1 minus x square. Okay. So this is the derivative of sine inverse of x. Okay. Let's find out derivative of tan inverse of x. that sine inverse of x, you can use the same steps to find cos inverse of x. Okay. Y equal to tan inverse of x. So your x is tan of y. Okay. Differentiating, you will get 1 equal to sec square y into dy by dx. Okay. So dy by dx is equal to 1 upon sec square y. So here you can directly write, as we know the identity, that 1 plus tan square x is sec square x. Correct? So we can write here 1 plus tan square y. Okay. So in place of y you can put this tan inverse of x. Square you have to write outside. Tan inverse of x square. Okay. Tan of tan inverse of x is x. So this becomes 1 plus x square dy by dx. Okay. And this is what inverse x belongs to R. Okay. So you should know the domain. Here it is given in the table. Cos inverse, it is domain is -1 to 1. Same for sine inverse. Cot inverse, it is R. Sec inverse, it is minus infinity to -1 and 1 to infinity. Cosec inverse, minus infinity to same. Okay. Next, it is exponential and logarithmic functions. Okay, they have given some examples. So we know that derivative of e raised to x is e raised to x. So what is the derivative of e raised to minus x? So you have to write derivative of e raised to minus x is e raised to minus x and derivative of minus x. So that is minus 1. So this answer is minus e raised to minus x. Then sine of log of x. Okay, d by dx. So this is composite function. Sine, derivative of sine, you have to write first. So this becomes cos of log of x into derivative of log x, that is 1 by x. Okay. Then cos inverse e raised to x. Okay. Derivative of cos inverse is minus 1 upon root of 1 minus x square. Here your x is e raised to x. So e raised to x square into derivative of e raised to x, that is e raised to x. So this I can write root of 1 minus e raised to x square means this terms gets multiplied, that is e raised to 2x. And here it is e raised to x. Okay. Next is e raised to cos x. Okay. Derivative of e raised to cos x is, first you have to write derivative of e raised to x, which is same thing, into derivative of cos x minus sin x. Okay.